Alright guys, we're going to start going over the pre-assessment with you. I'm going to go over some test-taking strategies with you just to give you an idea of what to expect on the EOC and making sure you guys understand the thought process as to how I'm able to eliminate some answers and how I'm able to choose the correct answer without really doing the math behind it. So let's start with number one. I kind of already did it for you. The basis behind number one is you want to plug in the inputs to hopefully get the output. Given table/function questions, if they give you a table and you need to match the function to the table, all you really have to do is, all right, I'm going to plug in 3 for x. Once I get 3 out, I'm pretty good. But if I get 3 out, I'm going to plug in 4. Now if I get 9 back out, I know I have the correct function. So again, if I plug in 3 cubed is 27. Well, I'm supposed to get 3 out. So that's not correct. If I plug in 3 again, 3 cubed is 27. 27 minus 3 is 24. I'm supposed to get 3. Now obviously I have C circled. Let's check out D regardless. 1/3 times 3 to the 3rd power. So 3 to the 3rd power is 27. 27 divided by 3 is 9. I'm supposed to get 3. So by process of elimination, A, B, and D are gone. That leaves C. C has to be the correct answer. If you actually plug in 3 like I did up here, and you plug in 4 like I did right here, you get 3 and 9 back out. So again, you get the matching outputs to the inputs from the table. Number 2. Number 2 talks about a car comparing years to the value. And again, since years purchased, it says 2, 4, 5, and 8. And we are trying to figure out which function best models it. Now, if I'm looking at these two types of functions, I have 2 exponential functions and I have 2 linear functions. Now, if I'm looking at the linear functions versus the exponential, and I'm looking at this table, the table's kind of hard to read. All right, it goes from 2 to 4 to 5 to 8. So unless you really start doing some math, it's going to be difficult to figure out what the rate of change is. If there's a constant rate of change, you can go down that road if you want to determine whether or not it's exponential or if it's linear. But I advise against it. Instead, look at your answers. If I'm looking at my answers, there's some big alarming exclamation points that should pop out to you. First and foremost, if I'm plugging in t for years and I'm multiplying 0.97 times t, again, this is the percent. So I'm taking 97%. This means it's losing 3%. But why would I ever multiply the percent by the year? That doesn't make sense. We always multiply percents by the amount, not by the year. If t represented the amount, then maybe this would make sense. But the fact that we're multiplying it by 2, 4, 5, and 6, that makes no sense whatsoever. So B and D are gone. It's between A and C. Now between A and C, given that it's an exponential function, we know that y equals A times B to the x. A is the starting value. A is the starting value. But if I look at my table, this is the first value I have, and this is the first y value. My starting value is not when x is 2. My starting value is when x equals 0. So 24,463 is not my starting value. That means this is automatically gone. That means, again, the only answer that makes sense is C. And again, you could have found the common ratio. You could have divided B by D, or it's not, sorry, B by D, this number by this number to figure out the common ratio, and you would have been like, oh, it's, well, 0.03, and then you would have gone on and figured out, okay, what is going to be my starting value, and you could have worked backwards. But given this case, none of the other 3 choices make sense. All right. Number 3, the graph of which function passes through the points in the table below. So again, we're not talking about building functions right now. We're literally matching functions to tables. So let me look at my x's. My x goes from -1 to 1 to 3. As that happens, I go from 12 to 3 to 0.75. So my y values are getting smaller. If my y values are getting smaller, that means I have a decay. If I have a decay, that means my b is less than 1. Because think about it, if my b is larger than 1, that means it's 1.5, 1.75, 2, 2.5. Regardless, you're growing. That means the numbers will be getting larger. So again, notice guys how I'm using annotation to really help myself get my thoughts onto paper. I'm not just trying to think it through, I'm writing everything down. So that means if I'm looking for a b less than 1, a and b are gone. A and b don't make sense whatsoever. I'm left with c and d. So c is 2 times 1 6 raised to the x power, and d is 6 times 1/2 raised to the x power. Now remember, I'm trying to figure out what my starting value is, and I'm also trying to figure out what this pattern is. Now again, it gives me 3 values. It goes from -1 to 1 to 3. And if I'm looking at it, well, if I go from 12 to some number, if I just make a table here, I know 0 has to be here, I know 2 has to be here. If I think about it, I know I have to somehow get to 0.75, I have to somehow get to 3. Well, if I put 6 here, 12 divided by 2 is 6, 6 divided by 2 is 3, 3 divided by 2 is 1.5, and 1.5 divided by 2 is 0.75. So I kind of filled in the gaps before I even made the function. So I know my starting value is 6, that means c is automatically gone, and again I'm dividing by 2, so it has to be d. So again guys, with this building functions, it's important to figure out what the pattern is first. Once you figure out the pattern, you can work backwards, find the beginning or starting point, and you're good to go. Alright? Let's move on to number 4. Number 4. It says, which set of numbers is part of the sequence that is represented the recursive formula below? That's terrible grammar, my bad. So recursive. Remember, recursive, guys, means we're plugging in the previous term. So again, I'm starting with 6. Again, a sub 1 means that is going to be my first term that I'm working with. And if I look, well, a sub n equals -3 times the previous term. So I'm just going to plug this in. So to get to a sub 2, I need to multiply -3 times 6, and I get -18. Well, this first off doesn't start with 6. This first off doesn't start with 6. So those two are automatically gone. And these two start with 6, but this one doesn't have -18. And the fact that we're multiplying by -3, guys, means we're going to be alternating signs. D doesn't even alternate signs. So notice how I could have just, without doing any math, and just by reasoning through this, C is the only one that makes sense. The only one that makes sense. Again, if I would have kept going, -3, I could have done a sub 3 equals -3 times -18, and I would have got 54, and you see I have 54 right here. You could have plugged 54 back in and got -162, and so on and so forth. Number 5, determine the explicit formula for the pattern below. So, my first term is 12, first term is 24, second term is 12, third term is 6, fourth term is 3, fifth term is 1.5. So, again, first and foremost, determine the pattern. 12, 6, 3, well, that looks like I'm multiplying by half. Dividing by 2, you guys probably thought that first, but again, remember, with these exponential functions, we're not dividing, we're multiplying. So dividing by 2 is the same as multiplying by a half. Well, these two are growth. So A and C are gone. Again, now I eliminated 2 answer choices because, again, I'm looking for a decay. This is a decay problem. So, alright, 24 and 48. These are both 1/2. Which one's correct? Now remember, if I have y equals a times b to the x, this is my starting value. This is also when x equals 0. X equals 1 here. So this can't work. My starting value is D. Again, guys, it's incredibly, incredibly important that you understand that A is a starting value, and that's when X is 0. That's basically, it's your y-intercept. This is where the graph crosses the y-axis. It crosses the y-axis at 48. All right? X equaling 1, that's when it hits 24. All right, let's move on to radicals and exponents because, again, that's where the struggle seems to be. 6. Determine the equivalent expression for m to the 3/5 to the negative 5th power. Well, let's first off use power to a power and get m to the negative 15th fifths, which is really just m to the negative 3rd. Okay? Because again, remember, power to a power states I can multiply these two exponents. So 3 times negative 5 is negative 15 over 5. Negative 15 over 5 is, well, negative 3. Now, with this, negative exponents. Remember, with negative exponents means I have to bring it to the bottom. Or if it's in the bottom, bring it to the top. So if I switch it, that's 1 over m cubed. And that has to be c. There's a lot of c's with this quiz, with this test. Which expression is equivalent? Well, now we have just a regular radical problem, guys. Remember, the very first step is to break apart that 8 into a perfect square times a number. Well, 8 is 4 times 2. 4 is the perfect square. Now, recall that when we're talking about variables, it's important to understand that the variable has to have an even exponent for square roots. If it has an even exponent, that means it's a perfect square. So x to the 8th is fine. Well, y cubed becomes y squared times y, because again, y squared is the lowest even number, and then y squared times y is y cubed. Z to the 32nd is fine. So, square root it, that's 2. Square root this, that's x to the 4th. Square root this, that's y. Square root this, that's z to the 16th. All to the 2y underneath. So if I look, my answer is A. Again, for simplifying radicals, you're looking for perfect squares. Number 8. Which expression is equivalent to that? So, this not only brings in your work with exponents, guys, this also brings in your work with radicals and understanding how to switch back and forth between the two. So recall, anything to the 1/2 power also means it's the square root of that anything. So this is actually 2 times radical 48 x to the 4th, y to the 5th. This just turns into a regular radical problem now. We just worked with one, same concept. 2 times, well, 48. What's a perfect square that multiplies to 48? 4 does. 4 times 12, but that's not the largest perfect square. The largest perfect square is 16. X to the 4th is already even. Y to the 5th is not, so I'm going to break it down to y to the 4th times y to the 1st. Let's start square rooting. Square root of square root of 16 is 4. And I'm going to multiply by this 2 on the outside at the end. X to the 4th becomes x squared. Y to the 4th becomes y squared. And then I have y underneath. I actually have 3y underneath because I have the 3 here and the y here. Now if I look, well, that's not the right answer because it's not 3y. These all are. 4 times 2 is 8. So that's 8x squared, y squared, radical 3y. Notice how this problem, this answer was put here because in case you got sloppy and did not multiply by the 2 on the outside. So again, watch out for these answers that could be correct if you made a slight mistake. Number 3, or 3rd page. Which expression is equivalent to that? Now, this is incredibly difficult because you kind of got to put everything into the same type. You can't just start looking at this and kind of guess what's going to happen. So let's see if we can't do something. I need to multiply or use the power rule here. First and foremost, I'm going to say this is 7 to the 1/2 times x to the 1/2. Because again, this 1/2 goes here, this 1/2 goes here. Now, I'm going to look at this separately. I'm going to say, you know what? Radical 49, that's just 7. That's straight up 7. Because the square root of 49 is 7. But I'm going to make this radical x, I'm going to make this x to the 1/2. Because recall, if I have 49x, that really means I have 7x, which is really just 7 times x to the 1/2, where the 1/2 only goes to the x. So I have this right now. If I kind of start working with things, I'm going to look at this and I'm going to look at this. Because if I multiply, remember when you work with variables and multiplying like bases, you add the exponents. 1/2 times 1/2 is 1. Or sorry, 1/2 plus 1/2 is 1. So I have this x to the first, I have this 7 to the first, and then I have this 7 to the 1/2 still. These are good. I don't have a fractional or a rational well, let's go back. I don't have a fraction as an exponent. So if I don't have a fraction of an exponent, I don't have to worry about radicals anymore. If I have an integer exponent, I no longer care about the radical. So I'm going to keep 7x as 7x. But this 7 to the 1/2 still has a fraction as an exponent. And I know 7 to the 1/2 is radical 7. So I'm going to put it as radical 7. 7x radical 7. C. Last one. Determine the value for x if I have 4 to the 2x minus 4 power equals 8 to the 3x plus 1. Now, when you guys are solving equations like this, it's important to understand that I need a common base. If I don't have a common base, I can't compare the two. 4 and 8. 4 and 8 can be rewritten with a base of 2. Because remember, 4 is just 2 squared. And 8 is just 2 cubed. And guys, remember, when you're working with this, I'm going to multiply this here and here. I'm going to multiply this here and here. Once I have the same base, I no longer care about them. All I'm worrying about is my exponent, because 2 to the 7th power has to be 2 to the 7th power. You can't have 2 to the 7th power equaling 2 to the 10th power. And if you're wondering where I'm getting these numbers, I'm just making them up. All right? 2 to x has to equal 2 to x. So if I can get these exponents to be the same, I'm solid. So that's 4x minus 8 equals 9x plus 3. Now I just have a multi-step equation. Subtract 4x, subtract 4x. That's going to be negative 8 equals 5x plus 3. Subtract 3, subtract 3. I have negative 11 equals 5x. Divide by 5. X equals negative 11 fifths. Boom. B. So again, once you get a common base, once you use the power to a power rule, just solve the exponents in an equation. Number 11, which situation can be modeled by the equation y equals 5 times 0.86 raised to the x power? Starting value, that's my a, this is my b, but remember, if I have 0.86, that means it's a decay, and I'm really losing 14%. Because if I have 86% of something, I'm losing 14% of it. So your Gatorade starts out at 5. That's good. That's a check. But it loses. I'm not losing 86. That doesn't make sense. Your 5-gallon jar, boom, starting value of pennies, and you lose 14% every week to pay your lunches. That works. Right now, that's a pretty solid answer. I'm going to read through the last two just to make sure. A pine tree outside of your window is 5 feet tall, boom, and it grows. This is a decay. That's wrong. Your bank account has $5 in it, boom, you're pretty broke, and it increases, but again, we're not increasing. This is a decay. If it's less than 1, it's a decay, so B is the only one that makes sense. 12. With college approaching, you decide to start researching the different loans you can take out. So we have two different loan options. You have the compounding interest formula there, guys. I don't know if they're going to give it to you or not. My advice to you, memorize it anyways. So I'm going to find both compounding interests, and I'm going to, well, subtract them because I need to find the difference between them. So the first one is, again, P means the starting value, 5,000, times 1 plus the rate. The rate is 0.054 because, again, we don't use the percent as is. It's divided by quarterly, so quarterly means 4, which is your N. N means compounded, so quarterly for 4 years. So N is again 4, T is again 4. When I crank this one out, I am going to get, well, It's A or B. I just don't have a calculator with me. So I'm going to say I get 6196.55. If you really get 7185.21, then yeah, okay, whatever. I know when I made this, I put both of them as the answer just to see if you guys were paying attention to the questions. So I'm going to say it's this. It might be that. I don't know. You get the picture. Next, I'm going to do 6,000 times 1 plus, all right, 6.1% turns into 0.061 over, well, it's compounded biannually. That means twice. And again, n is 2, and it's for 3 years, so I'm going to put times 3. And I'm going to say that equals 7185.21. If they're switched, then whatever. But again, the question wants to know the difference between the two. So I have to subtract this from this. Again, guys, always make sure that you have to answer the question that they're asking. So I'm going to take 7185.21, and I'm going to subtract, if you're wondering what I'm doing using my phone calculator, 6196.55. When I subtract those, I get 988.66. So again, always make sure you're answering the question at hand. All right? Moving on. Number 13, we're almost done. Which function can represent the population that is growing at a rate of 15% per year? T is years. So if it's growing at 15%, remember it's 1 plus r, which implies it's 1 plus 0.15, which implies it's 1.15. So I'm looking for a growth rate of 1.15. That doesn't have 1.15 in it. That doesn't have 1.15 in it. Actually, that's a decay, and that doesn't make sense. Now, if I'm looking at C and D, the 1.15 is our B value, not our A value. That's the starting value, not the growth rate. It's C. Again, guys, you gotta just think during these questions. Don't look at the math and be like, I don't know what math to do right now. A lot of math is just reasoning through a problem. All right, that's math right there. You don't have to write down an equation or a function to solve a problem, guys. You can just reason through it. All right, that's math. Last two. A particular type of cell doubles in number every hour. That's pretty important. So if it's doubling, that means it's a growth. Again, notice I'm annotating as I'm reading it. I'm putting down everything I think. All right, I know you guys do that in language arts. You should be doing it in language arts. We don't really do it that much in math, but it's a great tool, especially when you're taking a test, especially if you're a bad test taker. All right, you may do amazing in class. All right, but when you get to the test, you freak out. It could be very beneficial to just write down what you're thinking when you read through the problem. So doubling every hour means it's growth. And that also means it's exponential, which means it's y times a times b to the x. So if it doesn't look like that, I'm not using it. Which function can be used to find the number of cells present at the end of each hours if there are initially 4 cells? So again, if there's initially 4, that's also important. That means it's my a value. Well, these aren't exponential, so that doesn't matter. These two are. But a, that's to the 1/2. That's a decay. That doesn't make sense. It has to be B. B is the only one that actually makes sense. So if you're somehow missing this, guys, this is a basic, let me just look at it problem. 15. Monica did an experiment to compare two methods of warming an object. The results are shown below. Which statement best describes her results? Let me read these statements first, and then let me look through the table. So the temperature using both methods changed. So, okay, I'm looking for constant rate. I'm looking for exponentially increasing. Or then just method 2 is one of them. All right, so I'm comparing whether or not they're constant versus whether or not they're exponential. So let's look at how they're moving. That's plus 5. That's plus 6. That's plus 4. This is definitely nothing. That's nothing. That's not even linear. That's honestly nothing. It's just a function that I have no idea how to create with a function. I have no idea. All right, regardless. Let's look at method 2. Well, clearly they're not constant and they're both not exponential. So that leaves C and D. So notice how I went through the first one, I realized it wasn't anything, and I crossed out A and B. That means if you put A and B, that means you were just guessing because you had no idea. Because if you actually looked at it, it's not constant and it's not exponential. I'm not doubling, I'm not having. I'm not taking a third of everything. Can't be either. So that's plus 1.5, that's plus 3. Okay, so I can see right now it's not constant. So method 2 is definitely not constant. Just by eliminating answers, it has to be D, but if I look at it, that's times 2, that's times 2, that's times 2. Well, it's doubling, doubling, doubling. So it has to be D. Again, guys, that was exponentials. You saw how I was eliminating questions as I went around. You also noticed how I was writing the answer, annotating as I was reading the questions. That's incredibly important. Please, 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 while you're doing this, please do that on the EOC. Please do that from just here on out when working in math. It can help you immensely, all right? So hopefully you got what you needed from this. Hopefully you realized your mistakes. You're like, oh, I'm not going to make that mistake again. But let's be honest, you probably are going to make that mistake again because it just takes a while to learn from your mistakes. So that's it. Keep working on those assignments. If you guys have questions, let me know. I'll be glad to answer them. Otherwise, I'll see you guys later. Peace out.